Hello, this video is to talk about GCSE chemistry for the AQA specification, and it's unit 4.9, chemistry of the atmosphere. And I'm going to start off with the first two subtopics, which is to start the proportions of different gases in the atmosphere. Now, this, first of all, starts with us realizing that the atmosphere is a mixture of different gases, and it is actually variable exactly what you will have in any particular part of the atmosphere. But we can talk in broad terms of the most common gases that are in this mixture. Now, the table showing just now gives you the AQA specification percentages, and then the percentages you get if you look this all up on the internet, and I'll try and explain why there's two different ones. So the most common gas is always nitrogen. Please make a note of these. Make sure you learn these. It will come up. It's a thing that could be asked for you to perhaps get given a pie chart and explain which gas makes each part of it, or to get a table and fill in the percentages. So the most common gas is nitrogen. The second most common is oxygen. Now, if you look at the first row of figures, the slightly more specific and accurate figures, they are for what's called dry air. So if you look right at the bottom, there's 0% water vapor. Now, the AQA specification lists about 80% and about 20% because, of course, there is always some water vapor and it does vary. So actually, they are compatible with each other. So make sure you know nitrogen is the most common, oxygen is the second most common, and then depending how moist, as it were, the atmosphere is, argon at 1% or the water vapor, and then carbon dioxide, the gas that you'll hear about more later on in this topic, is only 0.04%. It really is quite a small percentage. And AQA, for all three of these, they just say small proportions. Okay, as well as knowing about the current atmosphere, we have to know about the early atmosphere. So again, please make notes as you go through this. First thing to point out, everything here is only a theory, because of course this all happened such a long time ago that it's very difficult to get any evidence. Now, I've put the word billions in capital letters because the exam board won't accept if you put millions of years ago. You have to put billions of years ago. In fact, 4.6 billion if you want to be specific. So what do we think we know? Well, a long time ago, the Earth wasn't like it is today. It was a really hot and volcanic place. There was no life. It was very, very different to the rather frosty day outside as I record this. The key bit about what I'm saying there, very hot, which means that all of the liquids that we have on the surface of the Earth would exist as gases in those days, and the volcanoes, that is the source of the atmosphere. So where did the gases come from? To start, they came from volcanoes. Now, there are three most common gases in this ancient atmosphere. You need to know these. Make notes of this. The main one, carbon dioxide. The second biggest one there, water vapor. There was also some nitrogen. It sometimes gets kind of missed out, and it seems a question of where does the nitrogen come from? Well, it was just always coming out of the volcanoes. There are some more complicated theories about it, but just the idea, if you put that nitrogen came from the volcanoes, that's going to be okay, and it's the one that's really going to be kind of unchanged in all what goes on. Crucially, they might ask you which planets are like this just now. The main one is Venus, but also a bit like Mars. Venus is the one I would go with. Okay, so you need to be able to compare what the atmosphere is like now and what it was like then. So here's just a quick recap. Billions of years ago, carbon dioxide, water vapor, nitrogen. Now, see if you can do it before I press play. Nitrogen number 1 and oxygen number 2. You've got now to be able to understand and explain why it changed and how it changed. So I'm going to go through all of these in order. Again, just make key notes like this. First one, where did the water vapor go? Well, as I said before, the Earth is really hot, and of course, now it's really not. The Earth cooled down, and the keyword, I'm going to put the keywords here in capital letters. These are what you need to make sure you include to get all the marks, particularly if there's a 6-mark question. So the Earth cooled down, and what happened is the water vapor condensed. It went from being a gas to being a liquid, and that's where the oceans came from. All the water vapor that was in the atmosphere condensed, and we have liquid water. Right, next one. The oxygen. There was no oxygen to start. There is now oxygen, otherwise we'd all be dead. Where did it come from? Try and see if you can think before I go through it. Hopefully, what you worked out is the life, the experience, the evolution of life out there. Initially with algae, about 2.7 billions, but then plants came along, and both of these things do photosynthesis. You need that word in your answer. The oxygen came from photosynthesis. Please pause and see if you can do the equation for photosynthesis, both the word equation and the balanced chemical equations. Okay, so plants take in carbon dioxide, they take up water, and then with sunlight, I haven't written it on there because it's not a chemical, but above the arrow you can write sunlight. And what they do is they form glucose. It's their way of making the glucose, which is their energy source. And the oxygen is just released as a byproduct there. So as all this photosynthesis was going on, the amount of oxygen in the atmosphere went from nothing to now 20 to 21%. Balanced equation, 6 carbon dioxide, 6 water goes to C6H12O6, which is glucose, and 6 O2. So just remember the number 6 for this. Okay, this is a 2 for the price of 1. Can you think what this equation backwards would be called? So if you look at it going backwards, glucose and oxygen giving off 6 carbon dioxide and 6 water, that would be respiration. 2 for the price of 1. You're welcome. Right, so we now know that the water vapor decreased because it condensed. The oxygen increased because it was released during photosynthesis. So the last bit we have to consider, where did the carbon dioxide go? And hopefully you can already look back at what you've just done for oxygen, photosynthesis. So it's a 2 for the price of 1. The carbon dioxide went down and the oxygen went up. There is one more reason that the carbon dioxide decreased. And if you've ever had a fizzy drink, that's your clue. Sorry, that was the equation for the synthesis. The carbon dioxide dissolved in the oceans. So oceans are slightly fizzy. I don't recommend you go trying to drink them, but there is a small amount of carbon dioxide dissolved in them, but it also then ends up becoming precipitated. And if you remember from the chemical analysis unit, that means a solid forming out of a solution. And this led to these carbonates getting squashed down into various rocks. So carbon dioxide, first of all, dissolved, and then it ended up being part of sedimentary rocks, but it also, the carbon became part of the fossil fuels, which we will cover later on in this topic. Thank you very much.